So I'll check out with him. I think maybe I will need to take some time to think about it. But I will look back.
Break area.
Okay, I will check with him. I need to know this.
Afternoon, huh? That's very weird. Hello everyone, welcome to Multipath TCP. Thank you all for coming. I know that people will, it's a very tight transition time from the previous session, so people will be coming in a bit late, I'm sure. I'm Philip Eardley. Thank you all for coming. Yoshifumi couldn't come this time, the other chair. So the first thing is we need at least one note taker and somebody to check in the Jabber room if there are any comments and relay them to the mic. So we need a couple of volunteers. Is that who could volunteer, please? We're not allowed to start the meeting unless we have somebody to at least take some notes. So just capturing the main points of discussion. Thank you, Mia. Is somebody able to just keep half an eye on the Jabber room in case some comments come in from there? And relay any comments. You can't do both, can you? Go back in a minute. So Rolf, you've just come in the room. Is it possible for you to monitor the Jabber room, please? Thank you. So we have two meetings this time. So we got a meeting on Wednesday as well. Please remember when you come to the mic to say your name nice and slowly so people can understand it. It's very easy to say your name too quickly. Here's the usual note well. So just a first overview slide of what's been happening at this IETF. There was a hackathon at the weekend. I don't think anybody from Multipath TCP did our stuff at the hackathon. Does anybody did anybody actually do some hacking and wants to report it? Okay. There was a workshop on Saturday which covered a number of topics. There were a couple of nice talks there about Multipath TCP. If you go on the IETF 96 site, I think you can find the link to this ANRW, the abbreviation for the workshop. So if you want to look at those papers, you've got the link there. So we've got two sessions this time. The first one, the one today, is trying to cover the our chartered items. That's generally what we're trying to do today. And the one on Wednesday is trying to, if we need to wrap up anything that we discuss here today, maybe we've had a bit of a think over the sort of intervening couple of days, and we need a bit more discussion. So there's a kind of wrap up period. And then to cover any non-charter items, there's a few things that I think there's about 4 topics that people have told me about. If other people want a short time at that meeting on Wednesday, I'm sure we can make a bit more time available. And I'm also hoping that we get a bit of time to talk about rechartering on Wednesday. So what new topics we should add to the charter, or what we should delete, or what we should amend. We also always try and have an opportunity for anybody to come with implementation news. I'm aware that I was just in the TSV area, which I expect several of you are in, and there was a very nice little talk by Christoph about a bit of implementation stuff. I don't want to repeat that, but if anybody has implementation news and they want to share it, you're very welcome to come to the mic now and give us a update for a minute or two about your implementation. Nobody specifically requested it, so I was assuming probably wouldn't be, but now is your chance. Going. Gone, okay. If somebody wants to on Wednesday, that would also be very acceptable. We'll make some time for that. That's always great to hear about what people are implementing. So there are two main topics we're covering today. The first one is about increasing the version number of our protocol, our Mptcp protocol, and the second one is about progressing or finalising the protocol, the BIS document, and that kind of continues to the discussion we had at the interim audio meeting we had, I guess, a month ago now. Right, so on the bumping the version number, I mean, this is, I thought I'd just briefly frame the discussion. So our protocol BIS, this RFC 6824 BIS document, we basically got 2 choices. You can have the same version number for Mptcp as the RFC we've already got, or you can have a new version number, and I guess by implication deprecate our existing RFC. So the history is we had an earlier discussion and decided that we would bump the version number. I've given a link to some of the email discussion we had for that. We had some further discussion recently. There was at least some feeling from at least one person felt that we should revisit that decision. So we had a little bit of discussion at the interim, and I want today really to have enough discussion to see if we want to change that decision we made, I've forgotten, maybe a year ago, or whether we're going to stick with it. So on the pro side of why we should bump the version number, so this was in order to make MP capable reliable. That was originally why we the working group decided to bump the version number, and it also, as a kind of nice side effect, it meant it was simple to add some other new features that seemed desirable. So things like support for stateless server and load balancer, and saving option space in the SIM. On the con side, or at least the potential downsides, there'll be things like, well, you have to have some kind of transition between versions, and maybe these new features that get added don't seem that important, or maybe you find other ways of adding them in. So at the interim, it was suggested, when we discussed it, it was suggested that something that would be very nice would be to have some data on the importance, on how important it is to make that the signaling reliable. So Christoph has got a couple of slides to talk about that. And I think something else that will be interesting to hear from people in the discussion is whether the people with the actual deployments now are worried about this migration issue, or whether they think the deployments are kind of small enough and controlled enough that the migration would not be a problem. So that's the end of me trying to kind of frame this discussion. So Christoph, you're up first, unless somebody wants to immediately jump in. Okay, so we'll have Christoph will do his talk, and then it's then an open mic for people to say what they think about this, and then after some period, which I will decide, we will then see if there's consensus to change our original earlier decision or not. Is that on?
Hello.
Is the blue sheet making progress? Where's it got to, the blue sheet? Okay, it's making good progress. Thank you. Is this the right side?
So not much data to say. It's all blue.
Try one more time while you're finding your slides. It's somewhere off to the side here, isn't it?
Okay, so the question was about the reliability of the third egg in the Mptcp handshake. So the question was how important is this actually to Mptcp? As I said, spoke earlier in the talk at TSV, I said that roughly 6% of the connections are falling back to regular TCP. This happens due to middle boxes and so on that are, for example, removing unknown TCP options out of the SYN packets. Now, however, when we are talking to a server that does not have SYN cookies enabled, then the fallback rate drops down to 4.4%. So this means that the only difference between both data sets is when TCP SYN cookies are used. And for those who have read the draft that we are discussing, it's basically when TCP SYN cookies are being used and the third egg gets lost, then Mptcp does a fallback to regular TCP. So this means that this data that we have collected on our servers at Apple means that 1.5% of all Mptcp connections are falling back due to an unreliable third acknowledgement. Now, I looked at the data and actually tried to see which kind of connections are falling back. And I looked at the subflow count. So we at Apple, we are using Mptcp for Siri on the iPhone, iPad, and so on, those kind of devices. There are many devices, for example, many people who use it on cellular networks, so there will only be one subflow. Many people who use it when they are on Wi-Fi and they have cell turned off, there will only be one subflow. There's also, like on iPad, many iPads don't have a cellular interface. They will only have one subflow. So I saw that roughly 30% of the connections have 2 or more subflows. So this means 70% have only one subflow. Yes?
So this is from the Siri dataset?
Yes.
And is this cleaned up? So is this filtered by destination, or is it just the whole data you have?
By destination?
Well, if you see the same device connecting to Siri twice, will it be twice in the dataset or just once?
Oh, so this means per Siri request. Basically, you take your phone, you
Over
take
all
out,
the,
yeah, and it creates a single
Okay.
Mptcp connection.
All right.
So, and then, well, it keeps the connection alive for a certain amount of time, for 2 minutes. And then if you just start a new one, then you get a new data point in this data set. Yeah. So 30% of the connections have 2 or more subflows. Now, I was very then surprised to see that those connections that lost the third egg have actually much higher rate of having 2 or more subflows. So 50% of the connections who lost the third egg have 2 or more subflows. So this was very surprising to me as well. And I think that it is because, well, there's a higher chance of packet loss on Wi-Fi networks. And so and when people are on Wi-Fi, well, then they have the cellular interfaces available as well, and so they have a chance to establish a second subflow. When they are on cellular, where packet loss rate is low, there will only be one subflow anyway, because no Wi-Fi interface is available. And then I looked at, well, at my data, how many of those connections who have 2 subflows are falling back. Well, it means 2% of the connections are falling back to regular TCP, or actually losing the third egg. 2% of those connections who have 2 subflows. That means 2% of those who actually could benefit from Mptcp. Of course, in order to get this data here, I needed to turn off TCP sync cookies, because otherwise we would have fallen back. And so this means that when we are on Wi-Fi, we have a 33% higher chance of falling back to regular TCP compared to normal connections, where we had 1.5% of connections falling back. Yeah.
So this was, how did you run the experiment? Did you control a number of items?
I'm just curious how you control the experiment. Did you control a number of iPhones for testing, or how?
No, I turned off TCP sync cookies on the server. Made sure that those connections do not fall back to regular TCP.
But did you sorry, I didn't catch the first slide. So did you directly control the client, or you only look at the servers, or how did you? Did you control some mobile phones that you use for testing, or how did you actually gather this data? Did you look at
We collect this on the server.
On the server?
Yes.
So then you said that in some cases sync cookies was enabled, in some cases it was enabled. So you played with on the server, you disabled, enabled.
Yeah.
Okay.
Yeah. So here last one. I know the graph is not very beautiful. I just made it a few minutes ago. So I looked at how many retransmissions do we have on those subflows who are losing the third egg. I was also kind of surprised to see how much the difference is. So on the x-axis, we have percentage of bytes retransmitted, which means basically if it is 100, this means basically among the amount of data, the useful data that is being sent, the exact same amount is also being retransmitted. And you can see that the green line is basically those connections without loss, and the blue line is those with loss. And we see that there are basically much more retransmissions with when there is this one packet gets lost, which basically means those kind of subflows would benefit more from Mptcp because they are experiencing more packet loss. And that is basically the data that I can present.
So just Philip Eardley, just make sure I understand this picture. So loss means you've got two curves. Loss means that the third ACK has been lost, and no loss means that it wasn't lost. And you're comparing.
That's right.
If the third ACK is lost, then what percentage of the total data bytes are retransmitted?
That's right.
Okay.
Yeah. And so the claim is that when the third ACK gets lost, that means that the connection in general has more packet loss, and which means in those kind of environments, MPTCP has even a bigger benefit, because in those environments where there's no packet loss, the benefit of MPTCP is marginal.
But the graph already reflects that. So
Kostin, you need to go to the mic, and it'll be Kostin for the purposes of the notes.
So, I mean, I see what the point you're trying to make, but this graph is in a sense obvious, right? So once you tell me, let's say there's a 10% loss rate because I lost the third ACK, then of course there'll be a 10% loss rate on the data packets. Therefore, I'll retransmit more.
Of course, yeah. It's not surprising necessarily. But that's basically why I'm making the argument that making the third ACK reliable is important, because it will allow us to fall back less and make MPTCP more predictable.
I guess that depends, right? Because if you actually exited Wi-Fi coverage and you switch to cellular, then yes, that would be the case. But if you don't, then you're stuck with this bad Wi-Fi, and you're going to use it no matter what, because users don't like to switch on cellular when they have Wi-Fi. So, you know, what you're saying is contingent on the mobility of the user, in a sense, right? Otherwise, it's
Yes. But yeah, of course it depends on the use case. For Siri, for example, many people use it when they are walking out of the home, when Wi-Fi is all on the way to become bad, on the way to become lossy. So, yeah.
And those percentages you got, how exactly did you count the percentages of times when you thought this impacted? So you basically counted all the instances when you had at least 2 subflows, and you took from that the number of
in those
failed
in this graph?
Yeah, in the initial numbers you showed.
In this one?
Yeah. So 1.5% means of
all MPTCP connections fall back. Yeah.
All right.
Okay. And then you mean the second one was the 2%?
Yeah.
Yeah. I counted those who have 2 subflows, and then counted those who have the lost ACK. Yeah.
Thanks.
Yeah.
So any more comments or questions about this? I don't know if you're prepared to answer this, Christoph, but so the other, or other people who have implementations and deployments, so the other, thinking about bumping the version number possible input is whether there is a potential migration transition problem. And I guess the people who actually have the deployments can comment on whether they would be worried about having to transit from a version 0 to version 1 MPTCP. So from your perspective, would that transition be a problem, or you would not be worried about that?
No, I'm not worried about this. No. The key here is that we know which servers we are connecting to and what the MPTCP version is deployed on those servers. And so we can make sure that we connect with the right client to the right server.
Question here. So I think this is a very good question to ask. So from the other people that have implemented MPTCP in the room and are running it in deployment, so we know of cases where the same party runs both ends, right? So, and in that case, for sure, there's no problem in transitioning. You can either stick to the current one or move to the next one. It doesn't really matter. The question is, are there currently use cases where you're actually interoperating with another stack, where a bump in the version number might actually mean temporary or longer term problems with Mptcp? So, if people want to come and tell us about this.
From Oracle. So how does this backward compatibility going to work? So there are going to be I cannot control the clients, I can control the servers. So what happens if a client with a different version number comes in, which means on the server side I have to support both versions of the protocol?
Yes, that's exactly the point. The additional functionality we're talking about adding, well, that's in 05 of the draft and so on, with the reliable, MP-capable and so on, and some of the additional functionality we're now talking about adding, and we'll be talking about later in the session about adding, in the assumption it's adopted, we'll have to add this to the protocol anyway. So the question is, do you make that either something that's negotiated within the same version of the protocol, implying that everyone has to incrementally start adding this, negotiated by a flag in the MP-capable and so on, or you implement it in a different version? And the way we talked about version numbers in the draft already was that you specify the highest version number that you're willing to support. That may well be. So if I as a client support version 1, I talk to a server that supports version 1, everything's fine. If I as version 0 talk to a client server that supports only version 1, it would drop it. But then it would drop it if the flags for the new features we'd asked for were also unavailable anyway. The only case it doesn't work is if you have a client that supports version 1 to a server that supports version 0. And yes, we'd hope that that would tail away over time. It's a longer term investment to create a stable and simpler protocol than having to create many elements of negotiation that would not be needed longer term.
Can we get some commitment?
Costin. Your comments don't count unless you use the mic.
So first of all, I'll sort of come clean and say that I'm the one that pushed for this bumping of the version number to be rediscussed, because I'm really worried about this transition and the fact that it might actually break what small deployment of Mptcp already have. And I just want to make sure that first we do it for all the right reasons, and there's good enough reasons to do it. And second, the reasons for which we're doing it are worth the pain we are going to take. Okay. So that's why I'm asking, first of all, okay, so Christoph is from Apple, and he can, currently they run sort of an island of Mptcp, so that's fine. When they decide to upgrade, they will upgrade. But then there's, I guess, the Linux kernel implementation that Samsung is using, and then there's the Oracle implementation, right? So then the question is, these two guys, these two parties, are they willing to upgrade, and are they willing to sort of make a concerted effort or whatever, right? It's because, if the client talks version 1 by default, that means the handshake when it arrives at the server, it's incomprehensible. And it's, the server will drop it, full stop, right? So it's actually a pretty bad outcome.
Well, yes, that's true, but that's about simplifying the server implementation. So it's not this incomprehensible, it's just it says version 1, and the server says, well, I don't support that, so I'm going to stop parsing it at this stage. Similarly, if we put a flag in the client that said, I want to do stateless operation, so it's still sent in a SYN that I support stateless operation, then if the server wasn't willing to, didn't support that, then what's it going to do? Drop it again? It's just a way of negotiating capability.
I completely agree. That the question is, how do you trade off the 2% that Christoph just put on the presentation with what's going to happen in practice with the problems of interoperability? in the short term or near term or long term, right? So it's really a trade-off in a sense. I mean, we're not really talking about the technical merits of the newer handshake. It's, you know, I'm sure that if we keep engineering, we're going to come up with a much better version, you know, that slightly changes over the years. But that's not how you do things. At some point, you freeze the protocol and you just, you know. So I'm also okay to bump it if we think it's, but we need to understand, you know, what are the benefits.
So why don't we make this a requirement that whoever is going to implement version 1 has to fall backward to version 0 if the server doesn't support it? Because that's going to be new development anyways.
The client has to retransmit to restart the system.
Right. I don't know about the specifics, but that has to be there for it to fall back.
No, if we make the requirement that a client has to always support the versions that are below him, I think in the draft we said the client who sends version number 1 and the server only supports version number 0, the server will have to reply with version number 0, and then the client seamlessly falls back to 0. If I remember correctly, that's what we have.
Yes, it can't dynamically fall back within the same connection, but it could cache that for future connections.
All right. Okay. Yeah.
Fundamentally, I think it is a trade-off between a short-term ease of transition for the limited implementations that exist versus a long-term simpler implementation that would be desirable.
I think also, like, what with add address 2? How are we going to handle this? Will we have to remove it out of the BIS draft? Because hosts will have to probe whether the other side supports add address 2 or not.
We could, if instead of making it a version number 1, we just put a flag that said, I support 68.24 BIS version rather than existing version, then you could make all these assumptions today and change the way that things look and so on. But that's kind of what a version number is doing anyway.
Except that, you know, you don't have the issue with, you know, one V1 client not working with a V0 server and having to do happy eyeball for Mptcp 12.
Yes, but it only would work if the V1 server also supported 3.0.
Sure. So I guess so are the Linux implementers happy with this? Will they implement it? And right, so because, you know, I guess there's Apple, Oracle, and Linux, right? The Louvain guys. So can we get some input from them? Christoph doesn't count as Louvain anymore. So.
Is Olivier or Fabian or somebody prepared to say anything? You don't have to. But
I don't have strong opinion on changing the version number or not. I think this will add complexity to the stack. It might be reasonable to do. The only thing I can say is that I don't think we have the resources at the university to do that. And there are companies that are doing products with a Linux stack on Mptcp, and I think they could do it. But I don't think they are in the room.
Where's Samsung?
That makes me uneasy.
And Rao, are you prepared to offer an opinion on this from the Oracle perspective, your implementation? Or
Ideally, we don't want to support 2 different versions. It's going to be one version that I think is going to be better. Whether you add flags or whatever, Bumping of the version number will cause definitely some problems for the clients. Now we are not in that Apple controls the clients; they can update the software. But what happens if somebody does not update their client? So we need to think about that as a working group. We can't have clients which cannot connect. There are always going to be clients, and I think that's the thing that worries me, is that there is no backward compatibility.
Forward, but there is backward compatibility if your server stack supports both versions. The only problem is with a modern client talking to an old server. That's the only way around that this would have problems. If you cared about backward compatibility enough to want to implement the multiple logics, which you'd have to do anyway based on the decisions we're making in this working group to extend the protocol. So you have to add all this functionality in there. Why don't we keep it simple for what we've got for the standards track processor we're working on here today? The whole point of this working group, the whole point of the BIS draft, is to refine the protocol based on the lessons we've learned. So why do we still want to keep hanging around bits of the protocol that are compatible with something that we've wanted to deprecate?
I don't have a problem with doing that. I think what you're saying makes sense, but my only problem is that our customers may have a client, old client, then what's going to happen with that? When it tries to connect to it, then we'll have to fall back to version 0 or whatever it is and implement that functionality. And that's the thing that might be a little bit problematic in the implementation. I don't know, maybe not, in which case we're fine.
I'm under the impression that if we want to add or basically apply the lessons that we learned from the original version of the RFC, the moment is now, because at the moment there are not yet deployments where a client talks to any Mptcp server that it is not controlling, at least as far as I know of. Like even Samsung, I guess they know which server they are talking to. So I think that if we want to change something, it's now or much later.
The other thing is, I think if you're going to upgrade the protocol, maybe we should enhance it to be able to actually communicate which version it wants to do it, because in the future we're going to run into the same problem.
It does. That's what the version field in the MPP bill is for. It says this is the highest version I support.
But that doesn't mean that I support the lower version either, because I may support just only one version, and so the server could not support that highest version. So it should be able to send back something saying this is the one I support, and then they can communicate.
Yes. So we've got if a client supports version 0 and a server supports version 0 and 1, the server could respond in version 0. If a client supports version 0 and the server only supports version 1, then it will drop it as invalid because we're moving forward. If the client supports version 1 and the server supports version 1, everyone's happy. If the client supports version 1 but the server supports version 0, then the server reports back it doesn't support that version. So that's the only case where you wouldn't get communication today. Well, sorry, you wouldn't get communication in this new world that you would get today if the stacks implemented everything, as in everything in 6824 BIS and 6824, which is just not the way we work around here. You know, we're trying to refine a protocol based on our experimental experience. That's why we're here.
So I think we all agree that this is going to be a large implementation effort, changing the version number and ensuring all of these compatibility issues. And it seems like a step function, like a step update, rather than something, you know, I add a small feature and then, you know, at some point maybe it's ready. So and we should not underestimate the software engineering effort needed to do this, and not discourage the guys that actually are writing this code. So I guess we've already had the part of the discussion, you know, can we support some of the features that we would like to have in this BIS version without bumping the version number? And what's the simplest way to do that? I think that's, to me, that's the most sensible approach. I mean, yeah, you can take the principal view that says we must increase the version number, but then if I list the benefits, you have I guess these 2% of the connections that will work, and then what else? I mean, what can you not do with a flag, right?
We gain a lot of space in.
So the option space. I hope nobody from TCP hears this, but I don't care about that, right? So I'm more interested in actually Mptcp seeing deployment rather than saving a few bytes in the option in the initial send. But that's just me.
Olivier Bonantu, based on the discussion, and if we look forward to other versions of TCP, I don't think we should be in a situation where when we are at version 5 of Mptcp, we have to support version 5.43210. So at least there should be a way for the server to say, I support this version and not the version that the client has proposed. And this is not, as of today, this is not possible. So maybe that's something that would be interesting to have a way to say, in a SYNAC, you propose version X. I cannot do version X, but I could have done version Y, and then it's up to the client to restart later. Because if we have that, then we can be in a situation where the server can support only one version, and then the client, if it has multiple versions, it can adapt to what the server can do, and otherwise it can decide to use fallback to regular TCP. Because we should not assume that the server can support any version up to and including version number X.
Alan, just to say, yes, that's a very good idea, Olivier. We should include that, because today we just say you would reply without the MP capable option. It would be much more sense to say, yes, I do parse your option, but I don't speak that version. That's an easy change. We can definitely make that happen, which might make multi-version clients work better. But to Costin's point about flags and so on, I really struggle to see how this can fit into the way a working group such as ours is designed to refine a protocol. If you say this flag in this header must always be set for this version of this protocol, and then everything that's specified in this document only applies to this flag is set in the MP capable option. Otherwise, we're going to use this version that we've deprecated in a previous document. It doesn't make any sense to do it that way. But we've got many more proposals about to come and be presented later about other changes to options that we might want to include in this. Now is the chance to make these changes based on implementation experience. Let's try and keep it clean.
Winter. So I think there's deployed code out there that shows that those 2% are important, and that's Google Chrome, because they open 3 TCP connections just in case one of them gets hit by packet loss, right? You could do the same with multi-path TCP. I'm not proposing this, but you could do the same to have more reliability. Just try 3, drop 2 if all 3 go through. That's one way to do it without bumping the version number. It's not very clean, but you could do this today. But it's very important to understand that 2% are very important.
Any more comments? Okay, so unless anybody objects, I'm going to stick with what I originally said. So we will now do a hum. You'll have a choice of 2. The first one will be that we stick with the original decision to bump the version number. And the second one will be that we change the decision and don't bump the version number. That second one will clearly need to be confirmed on the list, etc., because it would be a new consensus decision. Do we, of course, have some comments on the
on the wording of that? It's worth pointing out that if we decide now not to bump the version number, we then need to work out how we signal and implement everything we've assumed today based on the version number bump, such as change numbers of options, such as the lengths of the SYN, such as negotiating the options, and such as potentially any of the new features to be later discussed here, how we wrap those in to the protocol. So it's not a simple case as just rolling back, because we also need to say, if we're rolling back, are we also still wanting the additional functionality that we've wrapped into the draft? I assume we are. That's why the working group consensus was to add this stuff.
A fair comment. Do people, does anybody not understand what the two questions will be? Excellent. Okay, so first option coming up, we will stick with the original decision to bump the version number. If you agree with that, please hum now. And the second option coming up, we will change our decision and we will not bump the version number. If you agree with that, please hum now. So I heard consensus for the first option. Is that okay? That's right. So for the notes, I think there was good consensus for the first choice. Excellent. Thank you very much, everybody. Right, we'll now go on to the second topic for today. But I'm not being projected, which I thought I was.
Phil, can I ask a quick question to Christoph? So there was a question in the Jabber room. Can you reveal the number of samples you had for your measurement?
The number?
The total number, the absolute number? It was large, okay, good.
Can we now see that? Excellent. Okay, so we're now going to talk about the 6824 BIS draft. So what we're trying to do is to do a working group last call on this as soon as we can, to find out if people agree with, more formally, if people agree with what's in there at the moment, the new things that get added today over the next few weeks, and or whether people think there's stuff missing that they want to add. So before we send it to the ISG, our belief as chairs is that we will need some implementation. So we'll, depending on the results of that implementation experience, of course, we may need to do some further revision. So two people have asked for a slot about this. So Alan is going to talk about the BIS document and what happened in the interim and discussion since. And Fabian has got this draft here, draft Duchenne Mptcp add address, which has some suggestions. So he's going to talk as well. Alan.
So to mention the BIS draft quickly, because there really isn't much to say, it got revved to 06 before this meeting because there weren't really any changes since 05 other than a couple of corrections, thanks to Med for pointing those out. The point of this one is to talk about whether we want to wrap this proposal into the BIS draft. So this was presented in the interim. This is basically the same as what was presented in the interim, but the interim had about 6 people here, and here we've got rather more. So I think it's worth going over this proposal again and seeing whether we have any consensus in the working group as to whether we want to add this. This is work that has come out of a problem statement that Christoph wrote a little while ago about the need for Mptcp, whereas front-end proxies fronting a larger number of actual servers and needing to know where to route the second subflows towards. Whilst looking at the problem, Christoph and I realized that this is actually could be solved with a much more generic mechanism that's not specifically focused on just this load balancer scenario, and we could build a generic external authentication mechanism from it. I know this is something that Olivier had looked at a little while in the past as well. So we kind of condensed this into a very simple proposal in 2 drafts as to how to add this to 6824 BIS. So, you know, today's 6824 handshake, the keys are exchanged in plain text. We know that there's a risk there of attackers hijacking the session. We accepted that risk, and we pointed out that, you know, it's not really adding anything of any greater risk than TCP is today. It's just a model. This is just our leap of faith decision we make when we join a connection. However, a slightly more interesting thing is from the token generation. We generate tokens today as hashes of the keys, and there's a little bit of computational overhead there, but in particular the problem with collisions. If hashes collide, you've got to go back and start again, and you know, it's like shrug, what does it matter if you're dealing with 10 connections, 100 connections? When you're dealing with 100,000 connections, then you've got a considerably larger problem on your hands of dealing with hash collisions. So maybe generating tokens as a hash isn't a particularly scalable solution. Maybe we want to look at something else. So whilst looking at both the problem of load balancers and routing incoming connections and the question of tokens, we've come up with this proposal. Again, just another moment of reiteration. The current handshake, this is version 1, 6824 BIS handshake. The SYNAC contains simply the first 4 bytes, which is a negotiation about saying your capability. So it's a set of flags and the version number. The SYNAC sends a key for first the server side, then the ACK carries both keys forward back to the server. If you need to send data, i.e. if you need to make the ACK reliable, then you add condensed version of the data sequence signal in the option. So that's what we've got today. We've talked about the problems. So what we're trying to achieve is to make the token explicit. That would actually solve this problem. By making the token explicit, you can avoid the hash collision problem, and you can make it meaningful. You can put routing information in there to know which backend server behind your front-end proxies actually needs to handle this incoming connection. So that solves both problems quickly and easily. But how do we actually put this in the signaling? Well, the conclusion we came with was, let's completely decouple the idea of tokens and the idea of keys. Instead of that, you can exchange keys in the application layer somehow, and we can put tokens at the protocol level based on how we've decided things. Yeah. Actually, could you go back too quickly, Phil? Sorry. Yeah. So at the moment, we've got flags in the MP-capable handshake. The interesting ones are to the right of the flags. Currently only H is defined, and H is defined as what's in the draft today, which is I support a SHA-1 hash based mechanism of subflow negotiation and key token mapping. Basically what's in the draft is defined by H. We planned in advance for additional mechanisms to be added here by saying that whichever one of these other bits are assigned to alternative keying mechanisms, alternative handshake mechanisms, a client says whichever number he supports in what he sends, and then the server sends back in this response the one it chooses to do. So in theory, a client could set both G and H, and the server responds with just G or just H, depending on which one it wants to use. So we've proposing defining the G bit to mean a generic concept called application layer authentication. Skip forward to. So the SYN and the MP capable would look the same. The G bit would be set, and then the SYN-ACK comes back from the server with the G bit set and the server's token. This could contain some meaning. It contains routing information, for example, to say which backend server it could talk to, and some other random data, however the server wants to generate it. And then, of course, the client's token and the server's token is exchanged in the MP capable. Then when you come to join a connection, it looks exactly the same as it is today. Exactly the same. The tokens and random numbers are exchanged using keys. Now, this is basically as far as we want to go in the proposal of what gets added to 6824 BIS. G provides application layer authentication. What that application layer is should be out of scope, we believe, of 6824 BIS. We don't want to prescribe any way this works, which is why we've actually put this into 2 drafts, because the second draft talks about how to do this with TLS. So that's the end of the G-bit exchange. Then the TLS authentication says we use 5705 key exporters from TLS to get keys. And then those keys can be used at the application layer to sign the MP join messages and sign the add adra messages. But ultimately, it's up to the application. And because the application is under the control of both ends of implementers, they can choose which methods they want to do for this. We propose that bit stays out of 6824 BIS. So in summary, we've already changed the handshake to make it reliable by stripping down the size of the MP capable. It makes it even more logical to add some additional flags in there to talk about additional handshake mechanisms. So we're proposing the allocation of the G bit to mean application layer authentication to allow application writers to go freely into adding their own key exchange mechanisms, such as the TLS one I've described. Olivier, thank you again for the original suggestions on this.
Yeah, Olivier Bonanter, I have 2 questions. The first one, can you go back to the slide with the G-bit?
That one?
Yeah, so basically with that, you leave the option of using the application identification on the client side, because the client has to set the G-bit in the SYN plus MP capable that it sends. And one of the motivation is to also support load balancing by having an explicit token. And I'm wondering whether it would not be better to let the server takes the decision on whether to use the application level key and the explicit token or not.
Yes.
This means that you could get rid of the G-bit by just looking at the length of the token or key which is returned in the MP capable in the SYN plus ACK.
In the exchange we've got currently in 6824 BIS, there's no keys or tokens sent at all in the initial MP capable.
No, but I mean in the SYN plus ACK.
But so this is a simplified example. This is only if G is supported. What we'd expect is many clients would say G equals 1 and H equals 1, and then the server chooses to use application layer authentication by setting only G in the response it sets back.
Okay, and then the second question is for TLS. You assume that you will have a key which is derived by the application. And I have 2 questions on that. The first one is, do you use the same key on the client and on the server? If not, how do you derive these 2 different keys?
I'm trying to remember how.
Because typically in TLS, we have different keys for the client role and the server role. And these are derived in different ways by our RFC 5705.
Yes, but you can derive both, can you not?
Yeah, you can derive both.
Exactly. So that was the point. Yeah, exactly. So each end derives both, and then it's done in the same way it is today.
So you have 2 different keys.
Yeah.
So then the question is, with TLS, you can have very long TCP connection. For example, if you have a VPN, and in TLS, it's possible to change the key. What do you do if there is a change of the key at the application level? do you change the key in MPTCP as well, or do you don't change the key? Do you have a key rollover mechanism which is planned, or?
It would be changed because on every time you need it, you'll go to the key exporter. So if the key exporter provides new, it has rolled over, it will be providing a new key, is my understanding of 5705.
Yeah, but the question is, how do you, so you have a key from the application, will you pass it to the MPTCP implementation so that MPTCP has the key so that it can authenticate the MP join? Or every time you receive an MP join, you will pass the information to the application so that the application can authenticate the MP join based on the information that it received, based on the current key of the application?
The logic is the latter, so we pass to the application. However, that's out of scope of what we would be proposing for 6024 bits.
But
that's
if you pass to the application, then the application has to understand MPTCP, which is more difficult than just pushing a key with a set socket option.
That's a very good point.
I think with the session key renegotiation or master secret, we have to rethink a little bit the TLS draft that we added.
Yeah, and I would suggest to look at SSH as well, which could be a very good user for that. And if we can have a solution that works for both TLS and SSH, then I think we are safe.
I think in both cases, this is out of the scope of, I say, what we're proposing for 6024 bits. As we say, it's the application, it's up to you to define how that works. But it's interesting that you should suggest the idea of pushing a key down. That sounds potentially more flexible in some worlds.
But that's what Christophe has done 2 years ago. So
yeah, I think we haven't defined that well enough in the draft.
Yeah, but that's why we need to look at the implementability of the solution as well.
Thank you.
Hi, Subodh Iyengar. Just for the previous point, you can look at like how WebRTC does it, WebRTC does similar things like bootstrap the SRTP channel.
Absolutely, yes, yes.
Hi, question Archer. So I understand how this is supposed to solve the load balancing issues. The problem is you've now forced me, if I want to do load balancing, you've now forced me to use TLS, for instance, right? Or something that the client supports to be able to do application level key derivation. Because say I want to deploy my normal, port 80, whatever, HTTP over this. It's not going to work. So I will not be able to use MPTCP with this stuff.
Yeah.
So how does that work?
Isn't it a good thing that we mandate TLS?
Well, you mandate it, but not everyone uses TLS, right? I mean, it's not. I mean, and the next thing in the business, like MPTCP can only be used with TLS on top, and that's like, otherwise.
If you want to use application layer authentication, then you should use an application layer way of exchanging keys. That may be TLS. Yes, you could send it in the clear in the application layer. You could put something in the HTTP header that says, here's my key. I'm sure that everyone would love that for security.
The whole idea for this was to actually support load balancing, not for something else. And this doesn't, right? Or not for most applications.
Yep, okay. This is our proposal to assist in the load balancing problem and also solve some other problems at the same time. It's additional functionality, but is it actually a problem?
Olivier Bonanter, I think having the possibility for the application which has a better key than the one which is negotiated by MPTCP in clear to provide this key to MPTCP is a benefit which is independent of the load balancing issue. So I think that's a nice benefit to have. So that would be a good feature of MPTCP, and this is independently of the fact that we can support load balancing or not.
Thank you.
Are there any more comments? So I think we've heard today, thinking from the point of view of the protocol BIS, Alan's described a proposal for something to add to the BIS. He also described this additional TLS-related draft, but ignoring that, just concentrating on the change to the BIS. So I think we should think about whether we we add it to the BIS draft. So do people feel they've heard enough to be in a position to, if I do a hum about it, are people going to happy with me asking for hum whether we add it, or do people feel that they need more time to go and digest the idea and read more about it? So if you're unhappy with us having a consensus call now, please, because you need more time to ponder it, please come and let us know.
Julius Krobacek, something that's still not clear for me for that, perhaps I missed a bit. Is that something that every implementation must implement, or is that an option?
No, it's entirely optional. You list the crypto mechanism, the handshake mechanisms you support in your initial handshake, and that's the way it's negotiated. You list everything you support in what you send, and the server selects one of those in the response. So you wouldn't need to implement this. This does not affect you if you only want to implement what's in the draft today.
Thank you.
So before hum, I mean, if you decide to do a hum, I'll just sort of add my view of this. I think I like the mechanism. It's elegant, right? So I like the fact that with one bit you can get all of this. It's kind of neat. My problem is, so this was, I don't really know what problem it solves, because it doesn't really solve the load balancing part except for TLS traffic or for some other application layer protocol that derives the key, which, you know, basically TLS. And it doesn't really, I mean, if you don't think about load balancing and you think about what this buys you with TLS, it does give you a stronger key in a sense that, you know, that the key is not sent in the clear. However, Mptcp, when TLS runs over it, even if someone does get the keys and adds another subflow that's a rogue subflow, which is what you could do with these keys, you still have the protection from TLS, you know, and it's, again, I mean, I see sort of the use case. Maybe you get a bit better protection from like DOS attacks against TLS connections, but it's not really clear what you get. So as I said, I like the simplicity, but it doesn't really solve any real problem as far as I see. So that's why, I mean, unless we can find other uses for it.
The problem it solves is decoupling the token from the key, and then the benefits that brings.
Yes, but in the process, you've removed any other way of generating the key. So I like the fact that you choose your own token. I don't like the fact that you've now left the key in limbo.
Yeah, it's up to the application to sort it out.
So why not just say, if G equals 1, I'll give you the token, and I'll give you the key too. Well, and that would be much more useful, right? Because then I could use it for everything. Or, you know,
if G says I'll give you the token, and somehow you can get a key. Depending on the application, would need to be Mptcp aware, but it would get the key somehow. It could be
sure, but that's a very tall order, right? And the application needs to be able to get its own key,
but
right?
We don't have option space to send both keys and tokens, so that's why we're looking at this. You know, yeah, I'd love to do it. Actually, you know, that would have been great from day one. Would have been able to signal both, but we didn't have the option space to do it. Yeah.
Philip Diesel, TU Berlin. I have a question whether you have thought about a mechanism of signaling which kind of application layer key material you're trying to use. So we had the proposal of Bart also implementing this for SSH. So does it make sense to signal it with the MP join? Which kind of key material is used then in this step?
It's a good point. I think we've tried to keep this as simple as possible and said it'll be up to the application to make that decision. We're making the assumption here the application layer is Mptcp aware, and at that point it assumes it knows what client it's talking to, it knows what it should be exchanging. So an SSH server, so with Mptcp aware, could use an SSH key for this, and something like TLS would use a TLS key for it.
Walter Gluten, Soft@Home. If you say that it's up to the application layer, then that means that when accepting the connection, the server has to provide the key at that point in time. Is that correct?
No, the key can be provided later. The only thing exchanged at the SYN level, if you're using this, would be the tokens. So you would have to wait for the keying material to also be exchanged before you could open additional subflows. That's a noted limitation of this.
But the subflows are set up automatically without the application really explicitly needing to know about it.
Absolutely, and they wouldn't necessarily need to know about this, but the stack could only do this once it had been provided with keying material.
Because I have some concern in that if the, a couple of concerns in the sense that if the application needs to be aware to be able to set this up, then what do you do with front-end load balancers or aggregators like in the multipath TCP bonding use case? Which have absolutely no idea what kind of traffic is in there and have no particular protocol that they're aware of. And the other thing is the extra overhead of going to the application layer. Right now, you could set up a connection purely inside a kernel space, and you don't need a transition to user space to at this point in time. But with this additionally, you will need to have a transition to user space for accepting that connection.
Yeah, that's entirely fair. And it's a noted limitation, well, not necessarily limitation, but a noted restrictions in the scenarios in which this could be used. We're trying to solve some problems here and trying to make it as simple as possible by not prescribing anything beyond the application will provide some keying. I can understand the concerns. I understand it. We're not proposing this to be used in every scenario, far from it, but in a set of scenarios, especially those TLS scenarios where this could be useful, it's an easy way of plugging it in. And we didn't want to prescribe too much about the way it would be used, because there could be new ways it could be used by new applications in the future.
Right. Have you considered, I didn't see this in the draft, but have you considered what the application interface would look like? Because something in the acceptor or whatever.
No, and that's a fair point, because it was already raised earlier about in which direction does a key get pushed and so on. And that's something, yes, we probably need to look at.
Yeah. Could you consider an implementation of this that would actually reside in kernel space rather than in the application? So that it's just something that you provision the stack with, and then you just let everything work the way it does at the moment without the application explicitly knowing it and without the additional overhead.
I can't see why not, but at the same time, I can't see what could be used as a keying source for that.
Could imagine if the application can do it, so that you can have a module in the kernel that can do it, right?
Yeah, I think, and that's again another reason why we don't want to prescribe too much about the way this is used today. We see a way of using it, but the magic of the negotiation can happen down at the application layer, and we've got the TLS idea of how to do that. We can step back and say, well, someone else may want to use some other method in the future. It's a good point.
Okay.
Can you tell me your name?
I just want to say with what Costin said, with that it doesn't 100% solves the load balancer problem, which is, I think it's true, but for the load balancer problem at the moment, we have a bunch of different solutions. There are some who require each server to have a public IP address, which to some extent is possible, but only to some extent. Like some people don't have enough IP addresses. Then we have the one to decouple keys from tokens. And then we have one to communicate information inside the TCP timestamp or use a different destination port. So I think they are not canceling out each other. Like, for example, you could see here, for example, okay, if the client supports the application layer keys, then the backend can use this method. If, however, the load balancer receives a SYN with Mptcp without the G bit set, he forwards the SYN to the few servers that actually have a public IP address, for example. Personally, I'm not very sure if the solution of the different port numbers is really deployable in the internet, because of firewalls and so on, and relying on TCP timestamps. Yeah, there were also, I think, some question marks, but yeah. So I think with the load balancer, I think there are many solutions that might be deployed in parallel, and they're not canceling out each other.
Well, I agree with that. The thing is, there's two parts to load balancing Mptcp. There's load balancing the scene appropriately, which is what you try to do, and you only do it for HTTPS in the current internet. And there's load balancing the data packets. Okay, so the ideal design is where the load balancing can be completely stateless, in that you don't have to remember where you send the SYN to send the subsequent packets. Okay, so the solutions you mentioned that we proposed, both are completely stateless, in that every single packet will go to the proper server without any state of the load balancer, which means you can kill it and nothing happens, right? So in the token approach, for it to work, even for HTTPS, the load balancer must remember where it first sent the token, right? And then where it first sent the SYN, right? It must remember the SYN from the packet and associate it to the 5 tuple, and then when it sees other packets from the same 5 tuple. So there are different levels of complexity, right? It's not, I mean, yeah, that only does it for the SYN and only for some apps.
Olivier, I don't think we will solve the load balancing problem here now, but maybe something that we should do is to document the load balancing problem for the next IETF meeting, so that at the next IETF meeting there is a documentation with all the load balancing issues, because we know that there are load balancers, there are commercial load balancers that already support Mptcp. So it would be good to have information from these stacks that already support Mptcp. Yeah, determinate, we'll see. Yeah, but I don't think we have heard anything from people doing load balancers here, so it would be nice to have comments from them.
So Olivier, I guess you have the contacts in with them. Do you think they'd be prepared to help with something?
We'll see what we can do, but at least we can have a document with all the people in the room that are involved in the load balancing discussions, so that we can have something on paper which can document what we have, and that everybody can read this issue.
Right, so first describe the issues before we get any further. Okay. I thought there was some of that in the document, or...
Isn't that what Christoph document about a year ago?
We still need to use a working mic, and hang on.
But I mean that since then there are other proposals that have been, so there was Cassin's proposal.
Our microphone has...
There are different discussions on how to do load balancing, so it would be good to summarize them all in a document, and then see what are the pros and cons of these different solutions, and then we have the document, and we can decide based on the document to make progress. Yeah, we can revive the older document and add the other possibilities, so that we have a full picture of the problem space.
So regarding this whole load balancer issue, the main issue is that the load balancer doesn't get to know the token when it receives the MP capable SYN, right?
Then you can't choose the token. You can't put any semantics.
Well, the thing is, if the service operator gets to control both the load balancer and the servers, it can pick a key and then compute the token, and then send the key over to the server and force the server to use that key. Our draft proposes just that.
Yeah. The overhead to that is quite high, I think.
The overhead is only
You said.
There's a mic there and there's a mic here.
Okay. There you are. Right.
I think we shouldn't finish the discussion here. So basically is what Christoph said. So there's the overhead to doing that is actually very small at the server. It's not the load balancer is not big. I mean, we do, I don't know, 10 million packets per box or something. But the overhead is when the server has a collision, so it has already a connection with the same token, right? So that's when the server sort of has to brute force a new token, it has to find a new key that generates an appropriate token for itself, and so forth, right? So that's really the issue, and we haven't really evaluated it, so it's a fair point.
more comments or anything? So last time I asked, were people ready for hum? That immediately meant we had a whole lot more discussion. So I guess people weren't. So I'll ask again. Are people okay for us to have a hum on introducing this now, or do people want more time to think about it? I.e. not at this moment, but over the next few weeks? Okay, let's have a go at having a hum then. I'll ask three things. So first one is, yes, you think this proposal should be added to the BIS. The second one will be, no, you don't. And the third one will be, you want more time to think about it and have it discussed. So first one, yes, you believe it should be added to the BIS. If you think that, please hum now. And the second one, you think it should not be added to the BIS. If you think that, please hum now. And the third one, you think you need more, we should have more time and discussion before you want to make a decision about it. Please hum now. So I heard humming for all three and possibly more for the third. Costin's nodding, so we will have more discussion before we try and make a decision about it. So thank you. I think it was very useful, and I think there was certainly, it raised new ideas, and it raised some things that need to think about. And I think the idea of writing a document to actually summarize the load balancer problem is a very good one. So I think that's great. We've got some more work that needs doing and some ways forward. Thank you very much. Okay, so we've now got Fabian up to talk about the ideas he's got for adding in the protocol BIS. That mic is not working. This one is working. That one is working. I think I've sent a message to try and get this one fixed. Oh, how are the blue sheets doing? Where has the blue sheet got to? Can somebody hold it up? Med, it's at the back. Could you stick your hand up if you've not signed the blue sheet? So there's a few people, maybe it can do a quick whiz around. Which one of these are you?
Which one I see?
You're the address advertisement one, aren't you? Yeah. Hi. I found it.
Hi, so my name is Fabian Duchesne, and I'm going to present the slide on the Mptcp address advertisement that I was with Olivier at UC Leuven, Belgium. Next slide, please. Yeah. So the lessons we have learned from running Mptcp over the real internet is sometimes the rest of the initial subflow should not be used to create a subflow. That's the load balancing problem. I'll talk about more just after. That some address does not have the same importance. I'm going to give some use case for that. That an interface can have several addresses. The most obvious example is the dual stack host, but also you sometimes have several IPv6 attached to one single interface. And creating subflow is a costly operation, and sometimes you just want to minimize the number of subflow you established. So if you can reach the same performance with 2 subflows instead of 4, better stick to 2 subflows. Next slide, please. Okay, so just to sum up the problem we have with the load balancing today, because the load balancer are using the 5 tuple, so you send the MP capable, the load balancer will just stick your connection to one of the real server, usually based on the 5 tuple, at least for layer 4 load balancer. Then with the MP join is sent, nothing is guaranteed that the MP join will be, it will not have the same 5 tuple, and so it will probably be hashed to a different real server, and so it won't work. You will get a reset and only have the main subflow. Oh, and now I need to change slides. I wouldn't dare touch your computer. Yeah, I will try to spend a lot of time on that one. So our proposal is during the MP capable, when the server sends the SYNAC, the server must know that he is behind a load balancer, so the address, the virtual address, so 1234 cannot be used to establish subflow, so to send MP join. So the server in the MP capable will just send a no join option, telling basically the clients, do not try to establish subflow on that address, because that address is behind the load balancer, it's not going to work. Just after, here we suppose that the real server have several IP addresses that can be accessed without passing through the load balancer. So they have, like with IPv6, it's not that difficult. You just add several addresses that doesn't go through the load balancer. That's more like we do in direct routing, but with a public IP address. Yeah. There is no mic, so you speak. Yeah.
No, it works. We managed to turn it off.
You said this comes from some work. Is this something that is likely in the real life, so that a server is behind the load balancer where only part of his IP address space is actually load balanced, and there's another part of his IP address space that is not load balanced? Is that common?
Yeah, yeah.
It's common.
So 5, 6, 7 are private. Like 1, 9, 2, something.
Yeah, I mean, they are private. You just are more, it's in red just to show, but those are private IP addresses, and then you have public IP address like IPv6 address, where you can join the server directly.
Just to answer quickly, Julius Krobacek, in IPv6, we might very well have plenty of addresses on a single interface.
Yeah, that was not the question. There wasn't the question of the number of interfaces, but if some are behind the load balancer and others are not load balanced, it doesn't matter, just generally.
No, it's this one is going to do the trick. So after the sync plus with the no join option, now you know that you cannot establish a subflow on that address. Then the server will send another address with one of its public IP address that doesn't go through the load balancer. And then the client will send a sync plus to that address, and we have a working Mptcp. So what's the problem here? So that's the solution for the load balancing that we are suggesting. It just needs 1 bit. The only problem here is if we lose the ad address. If we lose the ad address, in that case, you will just have the master subflow and nothing else. You will just have one flow, because if the ad address is lost, at the current state of the implementation, ad address is not reliable, so you are not going to establish any more subflow. Next slide, please. So that comes to the reliability. So I just showed there, if you lose the first ad address, we suggest to make the ad address reliable by just echoing the option. So we just add an echo bit in the ad address, and when the client receives an ad address, it just sends the same ad address with the echo bit set to 1, so the server can check, okay, my ad address has been received by the client. If the ad address is lost, the server will just use a timer to retransmit it. It could be done probably with the RTO timer. Just add a timer to an address and retransmit it when it hasn't been echoed after a certain amount of time. So that's just basically just an echoing. I've heard other solutions, but if we use a bit to make it reliable, just because sending it over all the subflow or just trying to set it several times doesn't guarantee that it's going to be delivered. Christoph showed that 1.5% of the TERLAC was lost. Actually, the address is exactly like the third act, so it could be lost in 1.5% of the case. In the case of load balancing, that would be a problem. Next slide, please. Yeah. Make after break, it comes from the observation that we've seen smartphones that are connected to a server with a backup subflow, and in a lot of connection, I don't remember exactly how many, but we've seen plenty of smartphones with a backup subflow that was never used just because it wasn't needed. So in Mptcp, the only solution we have to put subflow in backup mode is first establish it and then say, okay, this is a backup backup subflow. You can also say it in the MP join, but still it will be established because it's during the three-way handshake. So we suggest to when a server sends an address or the client sends an address to advertise a new address, it can say directly, put the backup bit here and say, okay, this address is available, but please use it only when it's needed. So in that case, you can make after break. So when your subflow disconnects, the master subflow disconnects, then you connect the address that you have in backup mode. So it's kind of keeping the backup. It's just to fix when you have backup connections that are never used. It's going to save some energy and benefit utilization of smartphone. That's the idea. So only establish the connection when the main connection drops. Next slide, please. Priorities. The use case for priorities is typically a smartphone. For now, what we do is basically when you have a smartphone and you don't want to use the 4G LTE because it's method of whatever reason, you say, okay, I put my backup subflow, which is over the 4G LTE, I put my subflow in backup, and then you won't use it, except in certain condition. It's gonna mostly be unused. There could be another thing. For instance, if the Wi-Fi and the 4G are 10 megabits each, so you have 20 megabits, and the server, which is there, is pushing like video or something like this to the smartphone at 12 megabits per second. With the backup mode, you only have 10 megabits per second, it doesn't work. If you remove the backup, it's going to be load balanced. So you cannot infer how many megabits you will have over each interface. And if the Wi-Fi is bad and the 4G LTE is better, you will push everything to the 4G LTE, which is not really what you want. With the priority, you can say to the server, okay, the server now, the smartphone will just, when you establish the connection of send the MP prio, it will say, okay, I want you to prioritize always this flow, let's say the blue flow. So what the server is going to do, it will say, okay, it will just compare the priorities, like if my 4G LTE have a priority of 1 and my Wi-Fi 2, it will first completely fill the Wi-Fi subflow, let's say send 10 megabits, or completely fill the congestion window. And then when the scheduler sends the packets and you see, oh, okay, the blue flow is busy for the moment, then it will go to the lower priority, and then it will go to the 4G LTE. So in the best case scenario, you will have 10 megabits on the Wi-Fi and 2 megabits on the 4G LTE. This is between backup mode and just RTT balanced. It's just to allow the smartphone to tell the server or to tell the other end, which is pushing traffic, okay, please, if you want, please send most of your traffic over this interface because I prefer it. Next slide, please. Path diversity. This is mainly a use case to give more information to the other host when you had an address about the diversity of the path. So the single case, it's what I wrote in the draft, is the dual stack and multi-home server. So here, if you want to minimize the number of subflow, you want several subflow because you want diversity. But if you take the interface 1, you have like 2 IPv6 and 1 IPv4. In that case, 2 or 3 subflow could be sufficient. One for the IPv4 and the IPv6 of the interface 1, and the second one, then the third one for the interface 2. This is a very simple example, but basically, it's sometimes if an interface comes with plenty of address, it doesn't make sense to establish a subflow to all of this address. So Here we allow the server to specify the community, meaning those addresses are somehow related. It could be just because they are on the same interface, but you could also use the IP route to manually specify, okay, those IP, I know that they are going to use the same routes, and so it doesn't really make sense to establish the two of them at the same moment. So the community is basically allowing to configure the server to say, okay, those address, you don't really want to establish those two at the same moments because it's going to use the same path. Next slide, please. So in conclusion, we propose to integrate the modification into the 6824 bis. And that's it. I should just say I forgot, for the load balancer bits, the no join could also be used by a client to say to the server that he's being a NAT, and so you cannot use also that address for MP join. That was the second use case. I showed the server, but it also work for the client. Thank you.
Thanks, Fabian. So I think there were, if I counted right, 4 different proposals for adding stuff to the BIS. So I guess when you make your comments, you can make it clear which one of the 4 you're talking about. And we've got 20 minutes left, so let's plug your time.
I'll comment on all of them.
Cool.
The echo bit,
yeah,
like that. The no join thing, I like it. The add adra backup bit, yeah. So all those 3 seem like sensible additions that don't add a huge amount of overhead. They're useful features and could have quite a few potentially good uses to them. I'm puzzled by the community one though, for the path diversity. Surely if you knew your addresses were as part of the same community, why not just advertise one of them? Why advertise all of them and map them in a community?
Yeah, I mean, that's a question. Which address would you want to send to a specific server? That's what you're saying, right? Like you could just feed information to the stack and say, don't advertise those address to that kind of host, right?
Well, I don't really understand the use case of why you want
That's you just allow the other end to know more about the topology. That's you. I know it looks a lot like routing, right? It could be solved at the routing level, but it's just to allow the other hosts to know if the paths are common or not. Because for the moment you cannot. I mean, locally you know it, and you could choose to not advertise it. But if you don't mind, and it depends on the client, if he wants the to maximize the diversity without doing a full mesh, then community could be used just because, okay, then I could use the minimum of subflow. If you don't care about the number of subflow, then you just establish everything.
Yeah, but I'm still not seeing where the benefit is. If I've got an interface with 3 addresses on it, why would I advertise all 3 addresses with a community? And then the other end picks one of them randomly to connect to? I'm not seeing where the benefit is. Why don't you just advertise one and you know that one will then be used by the other end?
Well, I mean, for the moment, we always advertise the address in the stack, right?
It's up to your policy of what addresses you advertise.
I just see a big advantage for those dual stack scenarios where you have usually an IPv6 and an IPv4 address on the interface. In this case, not doing multipass over IPv4 and IPv6 over more or less the same path. I think for this case it makes sense. I also see no other use case at the moment.
Okay.
That's why it was in the presentation as an example, okay. But maybe I wasn't clear enough.
I'm not sure. Maybe I'm not convinced that's necessarily.
Come on, that's only 4 bits.
But
yeah, no.
Anyway, enough of that one. And then the priorities one as well. I'm a little unconvinced as to the.
Yeah, the priority schemes because I implemented a priority scheduler, and I was like, priority scheduler is cool because yeah, I can schedule wherever I want. But then you realize that most of the time when you want to use a priority scheduler, what doesn't really matter is not what the server wants to do, because the server usually, it doesn't really care about which link is being used. Usually it's the smartphone on the other end, which is important. So I ended up coding it with an experimental option, and I was like, no, it's not supposed to be like that. So if the server wants to make smart decision when pushing traffic to a client, he needs to know what the clients prefer, because if the server doesn't mind which link he uses, the smartphone certainly does, or most of the time it does. So it just allows the smartphone or any other kind of user, when you have basically a method and an unmethod connection, to say, okay, please use this interface when possible. It's not the backup. It's not the backup mode where you send nothing. The thing is just first you fill the congestion windows of the priority subflow, and then you fill the other one.
Oh, right. Okay, so kind of overflow.
Yeah, yeah. So if we have 12 megabits to send, please send 10 on the priority subflow and the 2 others. So it's because for the moment the backup mode is just all or nothing, right? Yeah. And here you can just make a very simple. I implemented it, a priority scheduler that will first push on the priority subflow where the congestion window is open. As soon as the window, when the subflow is unavailable, temporarily unavailable, then you send on the other subflows. So I ended up coding it with an experimental option. I was like, yeah, no, it's not always supposed to be, because it's a pretty common use case where a smartphone will say, okay, I can use the 4G, but please as less as possible.
Okay. I remain slightly unconvinced, but it's clear now. Thank you.
Rolf, I like the priority option actually. And I have a reason for this. So the reason why I like it is I think that will be good for hybrid access, because they are like what Deutsche Telekom is doing, right? They want to use DSL, and once DSL is full, then they want to switch. That you could potentially do. The echo option, so you just want to know that the address reached the far end and it's not using it. That's the only because it's using it.
It's in the draft actually. If you don't receive the address echoed, so if you don't receive the echo back, but you receive an MP join for that address, you just consider that it has been echoed actually. So if you just you could actually, an implementation could theoretically not implement the echo bit and just send the MP join, and it will be considered as but you have the case where the address has been received, but the client doesn't want to use it for the moment. That's why we use the echo bit.
So that's the only case, right? Because if there's a firewall that's dropping options, then you just retry and retry.
Yeah. So you will retry for a certain amount of time, but yeah, if you receive an MP join for that address, you can say, okay, I didn't receive the echo, but anyway, it seems like it went through. So then you stop retransmitting it, because
maybe
otherwise.
Probably do something like an exponential backoff or something.
Yeah.
Okay. Yeah, I think I had another question. I forgot.
Philip Erdley. So on this priority business and talking about the current, what it says about the backup being all or nothing, and you want more flexibility in that. So the other use case you've talked about is really an overflow. So I guess the question is, well, should you just have another flag indicating all or nothing backup overflow, or do you need this additional flexibility that this priority kind of feels?
No, because you have more granularity with the priority, because if you have like 3 or 4 interfaces, you can say, okay, this is priority 5, this is priority 4, this is priority 3, and this is priority 2. That's why I implemented actually. It's a single, in the kernel, it's a single integer saying, okay, the priority of this interface is that. And then it will start with the higher priority, 5. When 5 is full, you start with 4 and then 3. If you just was one bit to, if you just say overflow, backup, or regular, then when you have several overflow, you do not know which one you want to choose. Here it's explicit.
So have the use cases needed that degree of flexibility of defining?
I don't know, but
one, or I mean, you can obviously do an experiment and it's
I don't know if we really need 3 bits to do that instead of just 1 bit, but I mean, for flexibility, and so we don't have to change it later, I guess it's better. I mean, I was just like, if I only with 1 bit, it's less explicit, and if we want to change it later, it's going to be difficult. So, yeah. And also the 3 bits were because it fits in the MP prio, because I read the draft about MP prio again, and I was like, why is it called MP prio? Basically, for the moment, it's MP backup. So that's why I added the priority in the MP prio, because for the moment, it was just used for the backup. So now the priority come with the backup bit. So you have 3 bits for the priority and 1 bit for the backup.
So I remember my question. So with the priority, how do you define full? Do you do it over the congestion window? Once you have loss, it's full?
Yeah, if you look at the current FDRTT scheduler, which basically puts the traffic on the fastest RTT when the window is open, and then when the window is full, you just skip to something else. Then, yeah, there could be more discussion about how you code the scheduler for it. The option here is just allow the client to inform the server, okay, I prefer that one. Then I think we could discuss what kind of scheduler we want. I coded a very simple scheduler where when the congestion window is full, no problem, we switch to the next priority. This is a pretty simple example. It was just to test it, but yeah, I mean, we could make other rules like, okay, when the congestion windows is, or even based on something else of the congestion windows. I don't know. That's what I've done for the moment, but if you have an idea.
But congestion window is full. It's full all the time, but it's growing.
Yeah, no, I mean, when we are stuck, when you cannot send any data on the subflow. When the subflow is in
so it's basically lost.
Yeah.
Okay.
Actually, I'm also wondering, will we define in the draft how the priorities are being held? I mean, we have this overflow thing, because some use cases might not want to have an overflow thing. Some might have something else, and do we end up then again in a situation where basically it only works because the client knows to which server he's talking? How could we make it so that basically any client can talk to any server and they know exactly how it's going to behave? So should we define clearly what each priority means? So like priority 0 means backup, don't ever use it. Priority 1 means this, priority 2. That way you can basically for each subflow give a priority and yeah.
For the backup, so the 0 means backup. I haven't done that because it would change the backup bit everywhere, so I left the backup bit alone. Then, in my conception, this was just the higher priority is the better. So it wins over the other. But
how do you use the backup? How do you use
in my conception, yeah, in my conception, it was the higher. You push as much traffic as possible on the higher, the highest priority, and then so you push as much traffic as possible on 5. When 5 becomes temporarily unavailable, that's the function in the scheduler. It's temporarily unavailable because of some reason. Then you use the priority direct after, so 4 in that instance. When 4 is, if 5 and 4 are full, then you use 3. If 5, it's just pushing traffic, just following the priorities. The highest, the more likely you will use it.
Does priority maybe means something else than like let's say priority 5 means this is an interface or subflow that goes over a cheap medium, Ethernet. The other one means, okay, this is over cellular, so we should avoid using this. And the third one is, I don't know, let's say satellite. And so it's more like type of interfaces and the cost that is associated to them. And so based on that, the scheduling happens.
Yeah, I didn't thought about that. I mean, I just specified it like this because I needed it to just make priority scheduler. But yeah, we can, I don't know what you think about it. We can just put, instead of just a number, put more meaning in it. I don't know.
Rolf, so I think what you said is implicit because loss and delay will dictate how much you can push over that single interface. So if you go over, if you give the highest priority to satellite, it's going to suck. So it's going to very quickly move to something else. And then there's much more load on that other link, which has a lower priority. But I guess that's implicit, isn't it? Because if the congestion controller is basically deciding how much it can push over a path, there's an implicit priority. Or there's, well, yeah. It's kind of implicit. Yes.
Yeah, but that's not the case. For example, if you're going to bond a DSL and on a link which maybe have an upstream of 600 kilobits per second or something like that, and and an LTE link that might have an upstream of 10 megabit per second, it's going to side with LTE, and you don't want that because it's more expensive.
Yeah,
so
but the priority is local, so it doesn't. It will affect only your upstream.
And I don't think
So-
my LTE is doing that because it has really high delay.
We need measurements.
True, the delay will be higher, but the bandwidth is also much higher. Yeah.
Yeah, for the moment, the priority scheduler I made was based on the RTT, actually. It was almost the same, but just using the priority instead of the RTT.
Any more comments? Okay, so my suggestion is this draft has got 4 different proposals. I think, if I get it right, they're all independent of each other. So we should try and start some discussion on the list of each separately. And you know, I think we've had quite a lot of discussion about this priority field, so that obviously needs some more thought. But we haven't really had any discussion about the first 2, about the echo reliability thing and the reuse of the backup flag and the other message. So, well, we just heard a bit of support, but we haven't really had any discussion about them. So I think we should, you know, pick them off one at a time and see if there's consensus to add them or not, and you know, not to kind of let one of them dominate the discussion, which is where the others we haven't discussed at all. Well, I don't think we're going to manage to do that in the next 5 minutes, which is all we got left of this meeting. But I think it'd be really good. Maybe you should send some messages to the list about each one separately, each idea, and or do you want me to do it? We'll talk about it offline. Okay, so I think we're just about now. How the blue sheet's doing? Has anybody not signed the blue sheet? Perfect, excellent. You're all perfect. So just to advertise, now we're coming to the end of today's meeting, that we are meeting again on Wednesday at 2 o'clock in a different room in Tiergarten. So I've got 4 people who want to talk at that: Benjamin, Mohammed, Runa and Bart. If anybody else wants a slot to talk about some individual draft or piece of work they want to tell us about, that they're very welcome to ask me for a slot. We will also talk about rechartering in that session. So if there's something you think needs to be added, changed, deleted from the current charter, have a think about that so you're ready to contribute to the discussion. Thank you all very much for the active meeting today, and see you on Wednesday. Thank you. Bye-bye.
Basically one of the, so I'm like, yeah, it's like basically it's a set